In this video, we're going to learn or focus on writing quadratic equations. Now, if you remember, you must have 3 points or your vertex and one other point. If not, it's possible to make multiple quadratics, and we only want to make one unique quadratic. That's the entire purpose behind writing equations. Now, you can write equations by looking at tables, graphs, or even like word problems. We're going to start off writing equations given a graph. I think it's the easiest. Then we'll go to table and then in context. So in a graph, as you can see here, Desmos is more times than not going to give you 3 points if you have roots, solutions, or zeros. Okay. So roots, solutions, or zeros can account for 1, 2, or no points depending on the quadratic. Your max min is always your vertex. And then a quadratic, I don't care where it is always going to cross the y-axis, okay? So your graph, if you want to make a little note, you can always do vertex form, okay? And then sometimes standard. Now, note, determine which form you want to use, again, being vertex or standard. Just a quick recap. Y is equal to ax minus h squared plus k is your vertex. Standard form, y is equal to ax squared plus bx plus c. Where c is your y-intercept, y value, or the y value of your y-intercept. Your equation should have all points given. So a good way to go back and verify is to pull up a table, type in the points you're given, and it should be in that equation. If it's not, you messed up somewhere, or that's a good way to double check on multiple choice tests. Instead of having to remember all of the equations and formulas, you can just simply type the equations they give you, pull up a table, and check the points that you're given. Again, all points must show up. So starting out with a graph, this time we have 4, okay? So again, I said you can always do vertex form. So y equals a x minus h squared plus k. And Desmos is going to ask for these things called sliders. What sliders do is basically Desmos is recognizing that a, h, and k, or any variable besides a standard x and y. So if we let these be sliders, our a value we don't know quite yet. H value is our vertex, so is 2.5. Our k value is 2.25. And I know a is some kind of negative, but what negative, I don't know quite yet. Again, I'm going to come back up here and I'm going to click on this 2.5, 2.25. So I know the vertex is good. 4, 0, that's also good. 1, 0 is also good. Now I just so happen to get lucky here by guessing the correct A value. So say we didn't know the A value, okay? What you would do then is you would actually have to do this by hand and solve for A. So you would pick a point that's not your vertex. I'm going to use 1, 0 because it's the smallest. So 1, 0. And vertex, which is at 2.5, 2.25. And from here, I'll just plug it into the equation. Uh-oh. So y, the point you choose is x, y. So again, y equals a x minus h squared plus k. Y is 0 is equal to a. X value was 1. H value 2.5 squared plus 2.25. Again, we want to solve for A. So I'm going to subtract 2.25 from both sides. I'm actually going to do this parentheses and decimals. So 1 minus 2.5 and I'm going to square that value and I get 2.25. And again, remember, end goal is to get A by itself. So I divide to undo the multiplication. That then cancels, and I'm left with -1 is equal to A. Now another way you can do this is to input a table and again, remember we need 3 points. So 0, -4, 1, 0, and then I'm going to use 2.5 and then 2.25. Then I'm going to do this. I'm going to say y1. All right, this means y, the table up here, y1, is equal to, and then because I'm using vertex form or I'm using standard form, it doesn't matter. I'm going to do this one using standard form. So ax squared plus bx plus c. Whoops. So I forgot to put the x of 1 there. So ax of 1 squared plus bx of table 1 plus c.